Okay, guys, good morning again. Do you hear me? I hope. Alina, do you hear me? Okay, so I think we can start. Good morning, everyone. Again, so welcome to the third International League of the ВioTournament in Pushchina. I'm really happy and glad to see you. Yeah.
Oh.
Please just mute your microphone while somebody just say, because I hear myself right now because okay. So I think we can continue. I'm glad to see you again, I said. So we all of us hope that we can improve your skills and put up all of your knowledge and abilities today. So as you see, it is absolutely no format for us. It is online, and I strongly hope that everything will be okay and nice and smooth. So let's start. First of all, I want to start from introducing. And hello again. My name is Tatiana, and I am your chairperson today. So there is Alina Frolova, and she is a member of accounting committee. She will count your scores today. Now I want to check and to introduce our experts. So let's start. Berezhnov Alexey, PhD, Institute of Cell Biophysics, RAS. Do you hear us?
Yes.
Yeah, hello. Okay. Zayats Evgeny, Research Engineer, Laboratory of Biopharmaceutical Technologies, Timakin Avchennikov Institute of Bioorganic Chemistry.
Hello.
Okay. Petrova Anastasia, PhD, Belazovsky Research Institute of Physical and Chemical Biology.
Hello, good morning.
Yeah. Aladin Danila, Researcher, Institute of Basic Biological Problems, RAS.
Good morning, colleagues. Good morning.
Tutukina Maria, Senior Research Scientist, Skoltech.
Hello, can you hear me?
Yep, everything is okay.
Cool, but I was not able to change my name to expert, so could you probably do this on me?
Actually, I know it's you, so it is not
okay,
necessary.
Cool. Yeah, great.
Okay.
Great, thank you.
So we'll continue. Tutukina Maria, Senior Research Scientist. Oh, I'm sorry. Malavin Stas, Pushchina Scientific Center for Biological Research, RAS researcher.
Hi, everyone. Welcome.
Yep. Bella Bokan, PhD student, team Pathophysiology of Neuromuscular Diseases, Department of Translational Medicine and Neurogenetics, Institute of Genetics and Molecular and Cellular Biology, Strasbourg.
Hello, guys. Good morning.
Yeah, okay. So let's check our team. And Rubisco, are you here?
Yes.
Okay. My biochemical romance.
Good morning. We're here.
Okay. And Vichikova?
Yes, we're here.
Okay, cool, guys. So I think we can start our scientific fight. First of all, we should have Captain quiz. And it is new format, so you should be attentive what you really need to do with it. So first of all, you need to send me your answer just in chat with me, with host, with Tatiana Abramova. Not for everyone, chat, but just with me. So please choose it right now for not to lose your time.
Excuse me, chat on Telegram, VK.
No, chat in Zoom.
Okay.
Okay. And now that's the rules. I'll show you the slide with the question. You will have just 20 seconds for typing and send me answer. So be attentive and be fast, please. Actually, as you remember, it is English League, it is international league, so you should send me your answer in English. Okay. Are you ready, guys? Captains, are you ready? Just say, please. Okay, so 20 seconds. Start. Time's up. Okay, we have two right answer, I'm sorry, from Natalia Kulipanova and Sucheva Valeria. So now we should just another question for detecting our winner. Please, it is numbering question. Please give me your answer in kilograms, like number kilograms, okay? So you still have just 20 seconds, I'm sorry.
Is it okay that we
No,
can't
it is not okay. So, yeah, I have some technical problems with my computer. Just a second, please. I just tried to reload my demonstration of off screen. Okay. Okay. Start. In kilograms. Time's up. Okay, actually the right answer is 12,000 kilograms. So Saicheva Valeria was close than other guys. Actually, Kirill Dmitriev is not the the participants of this quiz because he failed previous. So the winner of the Capitan quiz is Saicheva Valeria, and she need to decide which line in the table she choose for every teams in this quiz, in this section. Saicheva Valeria, do you hear me?
Hello. We would like to be as opposing team firstly.
Again, what?
We would like to be as opposing team firstly.
As reporter, opponent, or reviewer? The first.
As opponent.
Opponent, okay. And what about another teams? I remind you that you can't discuss it with your team. You should give me your answer right now.
Yes, it's okay. So should I now choose the first row for other teams, as I understand?
For which kind of team? Just name it.
Okay, Rubisco.
Okay. And the last one for Vichikova. Okay, I think we are ready to start our first challenge. So opponent is the team My Biochemical Romance and reporter is Rubisco. So dear opponent.
May I please tell that we have one more rejection, Vichikova number 2.
Okay, but actually you should send it to the organizer before the tournament, for the start of tournament. Okay. So please, dear opponent, which kind of task do you want to hear from a reporter? I remind you that you have just 1 minute. Rubisco, do you hear me?
Hello, everyone. Are you hear me? Yes.
So I have just 1 minute for choosing a task.
Repeat, please. Number task.
Okay, you can choose any task as you want in spite of 1 and 5. Oh, I'm sorry, 5 and 6.
So as opposing team, we would like to call team Rubisco for task number 2.
Okay, dear Rubisco.
Our team is ready. Our reporter is Kirill Dmitriev.
Okay, Kirill Dmitriev is a reporter who will be an opponent.
From opposing team, opponent will be Anastasia Malых.
And who will be a reviewer?
A reviewer will be Natalia Kalipanova.
Okay, it's good. So please, reporter, just start to prepare. You should show us your screen.
Wait for a minute, please.
Okay. You have time. Okay, so dear reporter, I remind you that you have just 8 minutes for your report. You can start if you're ready.
Okay, hello everyone. Our team show a decision about task 2, bitte nicht bitte. Problem statement. Task 2, bitte nicht bitte. Enzymatic protein hydrolysates have the highest digestibility index, therefore they are especially appreciated by consumers with digestive problems and also attract the attention of athletes. Consumption of free amino acids in food has low potency compared to consumption of protein hydrolysates. Therefore, the consumption of protein in the form of short peptides is the preferred form consumption. One of the limitations of the widespread availability of hydrolysates on the market is the unpleasant bitter taste of peptide mixtures. Identify the causes of the bitter taste of enzymatic protein hydrolysates and suggest ways to reduce bitterness using soy protein isolate as an example. The proposed solution should not be limited to the use of flavors. It should be scalable, acceptable for the food industry and for consumption with a plant-based diet. Examples of protein hydrolysates. Dairy milk is the hydrolysate of casein, serum hydrolysate. Plant origin, the hydrolysate of gluten, soy protein hydrolysate, pea protein hydrolysate. Meat and fish origin, chicken protein hydrolysate, collagen hydrolysate, fish hydrolysate, hepatic hydrolysate, keratin hydrolysate, beef hydrolysate. Hydrolysates of animal proteins, dairy, and meat fish have become the most widespread and widely used. However, in recent years, vegetable protein hydrolysates have been increasingly used in various industries due to the development of the market for vegetarian and vegan products and beverages, and due to the expansion of restrictions related to the ethical standards of the use of animal proteins for the production of certain types of products. On the slide is pictures preparation of enzymatic hydrolysate by method of enzymatic hydrolysis. Protein containing raw materials of animal and origin method enzymatic hydrolysis and peptides amino acids. Advantages of enzymatic hydrolysis over other hydrolysis methods. The process of protein hydrolysis is carried out under mild conditions. There is no destruction of amino acids. The hydrolysis process is flexible and allows the production of hydrolysates with different functional and biological properties. Low energy consumption, high environmental safety, and no additional cleaning of hydrolysates from salts and admixtures is needed. Preparation of enzymes and features of enzymatic hydrolysis. For protein hydrolysis, enzymes cultured with the help of bacteria are used. Protosubtilene rapidash, and with the help of fungal cultures, proteorezanes, rimoprotolene, actinomycetes, and protolene, protohydrolygen, and others. The enzymes of the pancreas of pigs and cattle also have high enzyme activity. Key features of enzymatic hydrolysis: the specificity of the cleavage of the protein molecule, as a result of which the amino acid composition of the resulting hydrolysis depends on the type of enzyme. Mild hydrolysis conditions, normal pressure and temperature, and a limited concentration of 3 amino acids. Properties of the hydrolysates. They consist of 10% natural proteins. They are hypoallergenic. They have high biological value and bioavailability. Bioavailability. They are characterized by high content of essential amino acids, peptides, and essential macronutrients, as well as small fat content. They are used to improve the consumer properties, taste, structure, and the biological value of the final products. Use in the production of prebiotic for the food, microbiological fertilizers, starter cultures for the dairy meat industry, enzymes, vaccines, bioproducts, food and cosmetics. In the future, on the picture will be information, we will see. The absorption of proteins. The body absorption of proteins influenced by various indicators such as the origin of the protein and the composition of the protein. The origin of the protein. Animal proteins are almost 10% absorbed in the intestines, so thus they're fully released for use by the body. Percentage of total absorptions of vegetable proteins, excluding soy, much lower. The composition of the proteins are known to consist of different amino acids. Disadvantage one or more amino acids may become limiting factor to the correct use of the others. On the pictures, soybeans and chemical formula called casomorphin. Soy proteins isolate production and processing of some properties. Scheme 1 exclusive chromatograms of enzymatic hydrolysis of soy protein isolate. Sorry. On the slide, you see general information about soy production and processing soy protein isolate.
Dear reporter, you have just 1 minute.
Okay. Sorry, wait a minute. Problem. It's okay. Soy protein isolate preparation and some properties. Table 1, molecular-wide distribution of peptide fractions in the composition samples pro-selected at different time intervals. Our decision, 1, flavorings. With the help of flavorings in the food industry, they change and taste and smell of products to a more pleasant one. Thus, people can yogurt with the taste of wild berries, sweeter milk, and other products. Ultrafiltration.
Dear reporter, your time is up. I'm sorry, but your time is up. Okay, so now it's time for preparing of opponent. Dear opponent, I remind you that you have 1 minute for answering questions. In case when you don't have any questions, you have 2 minutes for preparing. If you ask questions, you have just 1 minute for preparing. Do you have any questions?
Excuse me, I can show next slides.
Yes, because he had technical problems. I think, Tatiana, we can allow him to.
You can just
for about a minute.
Like click on it, like show it without any words.
1 minute, okay?
Okay.
Decision ultrafiltration, continuous method.
You don't have any time for reporting, but you can just click on your slide and just show it. And that's all.
Okay.
Okay. So now you can mute your microphone. And again, dear reporter, dear opponent, do you have any questions?
I don't have any questions.
Okay, so you have time for preparation. Your opposite speech, and time is going.
May I see the reference slide, please, while we are waiting for the opponent?
Please show the list of the resources.
Okay, thanks. No, the last one, please.
15. Yep. Type to the 15 slide, please. Nice.
I think I'm ready to.
Okay, cool. So let's start.
So, good morning, dear members of the Commission and colleagues. I'm representing the opposing team, My Biochemical Romance, and my name is Anastasia Malых. So firstly, I want to thank the speaker for his work. And I would like to point out some disadvantages of the solution of task. Firstly, in the beginning of presentation, you told to us a lot of information about types of isolates and other material about production of isolates, but in the task it is clearly said that you should talk about soy isolate. Also, it is not clear what problem exactly needs to be solved, because you talked about production of hydrolysates and isolates, but in the task it was said that it is necessary to consider the problem of bitter taste and solve this problem. I think it will be more correctly to talk about why soy isolate has a bitter taste, and to talk mostly about how we can solve it. And due to incorrect time distribution, we don't have much time to hear from you about decision, about solution of your problem itself. So it is not clear how we will get rid of the bitter taste. And also you talked about some enzymes, and it will be better if you can suggest some exact enzymes, but also to talk about advantages of presented solution is it is like good theoretical basis which you use in the solution of your problem. And I think that like finally the problem wasn't solved. So thank you for your attention. That's all I wanted to say.
Okay, thank you, Karen. Now we are going to polemic, and both of the sides have just 5 minutes. So you can start.
So maybe we can take a look on the reasons of bitter taste.
Reasons of bitter taste.
Yes, why the soy isolate has a bitter taste? You don't say about it at all.
In my opinion, when people eating soy protein, sorry, at the moment. I can say in my opinion, I think that bitter tastes soy protein in the chemical structure. Different substances give bitter taste, and that
So, but actually, like, why was what they have in their instruction or don't have in their instruction? Because not all proteins have a bitter taste, but like soy proteins, soy isolate, it has bitter taste. Why? Something in their structure. Okay, what actually? Because I think the methods of solution this problem will based on this theoretical material about causes of this bitter taste.
properties.
What?
Repeat, please, your questions, please.
So you talked about the bitter taste is because of structure. Actually, what? Why? They, for example, have or do not have some, for example, amino acids in their structure, and then they have a bitter taste, or why? Not all proteins have a bitter taste, you know?
Well.
So it's not clear. Like your methods, like in the end of the presentation, I clear clear understand that it is solution to get rid of bitter taste, yeah? So on which it is based?
I think that amino acids give bitter taste of protein, and number, structure, and number and structure give bitter taste of soybeans. Bitter taste.
The opponent and reporter, you still have time. You can discuss another questions, or you can discuss decision of the reporter.
So, okay, in the beginning of the presentation, I actually don't remember which slide it was, but you talked about some special enzymes. Can you give me some examples of the enzymes which can be used, or there is no such enzymes?
Another examples, enzymes.
Yeah, some examples.
I don't know. I know that enzymes so isolate milk, fish, general enzymes. I don't know different enzymes and another enzymes. Sorry.
Okay, I got it. Actually, I think the polemic can be ended.
Okay, dear reporter, I agree with it.
Maybe the opponent can propose her own decision to this problem.
No. Oh, the expert.
But I'm not a reporter to propose my own decision.
I see, but
yes, absolutely. She can't speak about her own decision. She has to discuss this decision of the reporter. So it is not correct question. I'm sorry. So please, participants of this action, please turn on your camera when you're speaking, or when you report, or when you're opposite or review, because it will be more convenient for our experts. Right now, please turn on your camera. And Kirill Dmitriev. And okay, Natalia, I see. Okay, so now we are going to a review of this report. So, dear reviewer, you have just 1 minute for preparation. Let's start. Time's up, dear reviewer. You have just 5 minutes for giving your review. Let's start.
Hey, dear colleagues, my name is Natalia Kulpanova. I'm presenting a team ВioTournament. Let's start from the presentation of the reporter. He presented us plenty of text, and his presentation lacked pictures and themes. And even more, the reporter hadn't coped to present his decision on time. So I think he hadn't coped with his task. As for the opponent, she gives us the constructive critiques of the reporter's decision and presentation. She focused on the reasons of bitter taste, and she tried to make the decision better during the polemics. The discussion was not really productive. It was the fault of the reporter, but the opponent tried to get into details of bitter taste and to develop the decision to clarify the details of the enzymes. But the discussion was dwelling on two questions, while they can maybe discuss the economical part of this problem. Well, I think the opponent coped with her task. Thank you for the attention. It's all.
Have you finished?
Yes.
Okay, so we have 1 minute for reporter conclusion word. You can start, reporter, if you want to say something. Okay, as I understand, we don't have any word from reporter, so we can go to expert questions. So please, dear experts, if you have any questions, just ask it.
Yes, I have a question to the reporter. You have listed ultrafiltration as a solution on your slides, and the question is, which property of the product are you planning to change with ultrafiltration? What are you going to achieve with it?
Okay. This slide. I say about ultrafiltration method that filtration substance sorry, wait a minute. Ultrafiltration is common filtration substances, but on these slides, what slide number 12, slide number 13. Ultrafiltration, this scheme. Water, filtration, pollution, and another substances, and output of the filtrate, clean substance, which ready for the soy material.
So you are just going to use ultrafiltration to get rid of various small molecules. Did I get your idea right?
Repeat, please, question.
Do I understand you correctly that you are going to use ultrafiltration in order to remove various small molecules?
I think ultrafiltration use on the big molecules such as water. If you have small molecules, need more filters or another filters which filter small molecules and big molecules each other.
As I understand that we don't know what substances makes taste bitter. So how we can filter something, but we don't know what we must to filtrate. This is the problem I see. What substances make food bitter?
For example, another substances on this question.
Yes. In your method.
Okay. I think that substances, for example, soy proteins, can ultrafiltration same substances which have bitter tastes. Another vegetables which have bitter tastes, and we can see normal tastes.
Okay.
Dear members of jury, do you have any questions?
Yes, please. You said about, so your first solution was using flavors, right? So could you suggest some particular substances or some preparations? Do you have in mind anything so we can add you some scores for that? I will be direct. So have you thought about any concrete, any particular substances that can be used as flavors here in this case? Do you understand my question?
Yes.
Okay, thank you.
Okay. Flavorings we use in another use on the another products which have bitter tastes. Another vegetables. Also flavorings we can use in the products which on the fruits and another products of eating. Sorry, I very long to think. Sorry.
Okay, thanks.
Dear experts, we have time for the last question. Do you have it? Okay, I think we are done with questions from experts. Thank you, guys. Now, dear members of jury, you have time for thinking about this challenge again and consider what kind of scores do you want to get these guys. You have a minute for it.
Do we need to send the scores to you right now or later?
No, later I just ask you about these scores and you say it out loud, like in special order, like first of all for reporter, then for opponent, and then for the reviewer. And that's all.
Do I understand correctly that we should simply later post our marks in the chat?
No. Okay, I ask you about your scores, like one by one, expert, and you should just say it out loud
okay.
in chat. Yes, what do you want? Okay, dear experts, I hope you are ready. So let's start from Mr. Berezhnov. Could you please say your scores for the reporter, the opponent, and the reviewer, please?
Yes, I'm sorry. I would like to put mark 1 to the reporter, 8 to the opponent, and 4 to the reviewer. Because there was no solution, you know. So it's only 1.
So, okay, now Mr. Zayed, please.
0 for the reporter, 9 to the opponent, and 4 to the reviewer.
Okay, thank you. Now, Miss Petrova, please.
I would like to award 4 points out of 10 to the reporter because they still has
No. You can't do it. You can't explain your scores now. You just say scores, and after all of experts give us their scores, you can say your words as you wish, because now it's like some kind of pressure for an expert when you start explaining your scores before other scores.
Okay. So 9 out of 10 to the opponent and 4 out of 5 to the reviewer.
Okay, thank you. Now, Mr. Aladdin, please.
So I think to just To the first one, 3 points for how I don't remember how team name. Opponent 6 points and resistance 3 points. 3 from 5.
Okay, just for check it, 3 for the reporter, 6 for the opponent, and 3 for the reviewer, right?
Yes, for reviewer 3 points, yes.
Okay, and Miss Tutukina, please.
So I would give 3 for the reporter, 8 for an opponent, and 4 for the reviewer.
Okay, now.
Did you get it?
Yes, everything is okay.
Cool.
Mr. Malavin, please.
2 for the reporter, 2 out of 10, 8 out of 10 for the opponent, and 4 out of 5 for the reviewer.
Okay, thank you. And Balkan, please. Ms. Balkan?
Yeah, I will give the 3 out of 10 for the reporter, like 7 out of 10 for the opponent, and 4 for the reviewer.
Could you please repeat your score for the opponent?
7.
Okay, thank you, dear experts. Now you can say something if you want. Now you can explain your scores if you wish it, but please be accurate. You have just, I think, about five minutes for it.
Maybe it's better if their teams have the question for the expert. They can ask about some marks or something like this.
Okay, so dear teams, do you have any questions about your scores for experts, or do you have any questions for experts? No, you can ask it. Okay, as I see, nobody has questions, so we can go to the
I'm sorry, may I say just a few words to explain the future reporters, opponents, and the reviewers, why I lowered some scores. I wouldn't explain the first one. It's clear to me and to everybody, I think. But for the opponent and for the reviewer, I lowered the score a little bit because to me it looked like they just criticized. They didn't support the reporter, not by their solutions, but like some explanations, or maybe. So I think it's kind of important thing to support each other during this tournament. So this is my opinion. Okay, thanks.
Okay, thank you. I think we can go on and move to the second challenge. So just look at it. We have just seen the decision for the task 2. So now our opponent is Vichikova, and the report is My Biochemical Romance. So dear team Vichikova, we can challenge My Biochemical Romance on all of tasks besides 1, 5, and 2. So what do you prefer?
Good morning. My name is Victoria Ikonikova, and I would like to oppose the task number 6, the film supremacy.
My biochemical romance, are you ready?
Hello again, Wes. Yeah, we are ready, and the reporter is Chernova Veronika.
Okay, who will be an opponent?
The opponent would be Victoria Ikonikova. It's me.
Okay, and who will be a reviewer? Reviewer, are you hear me?
Oh, yes, yes. Reviewer is Orехova Svetlana.
Okay, thank you. Please not to forget about turn on your camera while you speech something, when you're talking something. And dear reporter, you can start to prepare for your presentation. You can show your screen.
So can you see our presentation?
Not yet.
While we are waiting for a presentation, dear Mr. Zayats, you have got to the previous reporter 0, but actually we don't have these scores in our system, so you should just change your mind.
Okay, then 1.
Okay, thank you.
Hello,
Yes.
dear members of commission and colleagues. Can you hear me?
Just a second, please. Yes, we hear you. We see your screen. And remember, you have just 8 minutes. So you can start if you are ready.
Okay, I will present a solution of problem number 6, the film supremacy. I'm from team My Biochemical Romance. And please, next slide. Firstly, our goal is propose strategies to treat disease caused by biofilm-forming bacteria given their growth or their antibiotic resistance. Next slide. And our objectives is to scrutinize the processing of biofilm formation. Next objective is examine ways to eliminate them, and in the end to consider methods of dealing with these microorganisms which cause the formation of biofilm. And I want to start this, what is it, our biofilm. It's a significant number of different enzymes are found in biofilm, many of which are involved in the degradation of biopolymers. The substrate for their enzymes is water-solved components such as polysaccharides, nucleic acids, and proteins, as well as some water-insoluble polymers, cellulose, chitin, lipids, and various organism particles captured by biofilm. Next slide, please. The main direction of treatment of biofilm bacterial infections are the development of, firstly, it's anti-adhesive drugs. For example, it's lysine and sodium peroxide, then introduced into the medium simultaneously. These bacteria negative affect both the adhesive process and the formation of biofilm by all stages. Next slide, please. On the other hand, we can use pharmacological agents what cause the destruction of the biofilm or prevent its assurance. For example, it's hitazan. It's an amino acid halide devoured the cryptocene cells, and the protein lactoferrin is effective against the biofilm. Next slide, please. Moreover, we can use silver nanoparticles to prevent the formation of microbial community with use of silver nanoparticles. The method is based on the fact that silver inhibits DNA replication, the expression of ribosomal and other cellular proteins, and interferes this the bacterial functioning of the electronic transport chain. As a result, silver nanoparticles inhibit the biofilm of Pseudomonas aeruginosa and Staphylococcus epidermidis and cellular proteins. Next slide, please. On the other way, we can use antimicrobial peptides. They can be used against the bacterial biofilms in Pseudomonas aeruginosa and Staphylococcus aureus stains. Their substance bind to fragments of the cell membranes of microorganisms, disrupting its stability. Next slide, please. Moreover, we can use bacteriophages. They play a significant role in the decomposition of biofilms. At the same time, their role is not limited only at the destruction of microbial cells. Many bacteriophages encode a wide range of enzymes that destroy exopolysaccharides that are found in biofilm. The use of bacteriophages can be an alternative to the use of antibiotics in the fight against biofilm. In fact, persistent cells what are resistant to many agents. Bacteriophages replication is in the biofilm destroying its structure. They can be used against the formation of the microbial community of Staphylococcus epidermidis and Pseudomonas aeruginosa. PACs have far fewer side effects than antibiotics. Next slide, please. The other way is passive rejection. It depends on the action of artificially added enzymes that damage the biofilm matrix of Pseudomonas aeruginosa. They include DNases and polysaccharide liases. The formation of biofilm is prevented by a number of D amino acids. You can also use RNases at the same level as DNases. If you destroy the mRNA or tRNA, what are involved in a protein synthesis, it's possible to stop the growing. Acting in a complex, they block the biofilm processing, cause the passive rejection of the biofilm, the addition of magnesium, calcium, or iron, smoothing out the antimicrobial film effects of microorganisms. Next slide, please. In the end, I want to present the solution. What I think the better of this, it's anti-staphylococcal immunoglobulin or hyperimmune anti-staphylococcal plasma. It's also can be used to solve this problem. Anti-staphylococcal immunoglobulin is a protein fraction of human blood plasma. The composition of hyperimmune anti-staphylococcal plasma includes anti-staphylococcal antibodies, which have a disruptive effect on bacteria as well as antibodies or their toxins. Next slide, please. In this slide, you can see my reference. And that's all what I want to tell you. Thank you for your attention.
Okay, thank you. Dear opponent, do you have any questions?
No, thank you. I would like to take my minute for getting ready.
Okay, so you...
Sorry, but I don't hear you.
I have no questions. Thank you very much.
Okay, so you can start to preparation to prepare.
Excuse me, our reporter has some problem with her microphone. Can she take a minute and deal with this problem?
Okay. While our opponent is preparation, plus they have time while she will opponent her speech, her decision. So I think she has something about 6 minutes for decision problem. The opponent, are you ready? You can start.
Okay, I can start, right?
Yep, absolutely.
Okay, good morning, dear colleagues and jury. First of all, I would like to thank the presenter for a really nice presentation. It was really well structured and was really informative. So yeah, I think that's a really good part of this solution. Let's talk about all these information that has been in this presentation. First of all, the method of using drugs to penetrate biofilm. There has been a couple of names, for example, sodium periodate and lizocin to use, but sodium periodate is a highly reactive oxidant, and so it might be not really good for human body. And lizocin might act on all bacteria that are inside our body, so it's not really good. Talking about silver nanoparticles, it's a nice solution, but I've heard that they can be toxic for human bodies, so it's a problem to consider. Antimicrobial peptides is an interesting solution too, but all these probable solutions have two main problems with them. Is that there is a big matrix of polysaccharides and etc. In which bacteria are in, and so it's hard to act on the bacteria inside. As I understood, the main solution is to use immunoglobulin to activate our immune system, and so that it can just fight biofilm itself. I hope that I understood it correctly. But I think that this solution is not really good because, first of all, there is a problem to consider that maybe our immune system can't detect the bacteria inside a biofilm because of this matrix that bacteria is underlying within. And the second of all is that if we will activate our immune system too much, there will probably be major side effects. Even sepsis is possible. And so we must take this into account. So yes, I would really like to talk on our polemics about how can we prevent probable side effects from overactivating immune system and to improve the whole solution. Thank you very much.
Okay, thank you. Dear reporter, do you hear us? Can you speak?
1 second, I just ask about sorry, our opponent, and then we will start our polemic.
Okay, thank you for your work, dear opponent. Firstly, what I want to say, what nanoparticles of silver don't affect their body, because in our day we have a lot of drugs or this component. For example, it can be used to treat the common of cold. And thank you for your attention about my problems in this presentation. Moreover, about immunoglobulin, also such as antibiotics, all of drugs and different therapy have influence on the body of a person, and any dose is selected by the doctor, taking into account the patient's constitution. That's all what you ask, and I tried to answer for your questions.
Okay, we have a polemics now, right? I can ask questions.
Yeah.
Okay, so how do you expect immunoglobulin to act on a biofilm, especially mature biofilm in the human body? Like, how do you think it will work? By activating immune system, or
sorry, but I didn't hear you.
How do you expect immunoglobulin to work on the mature biofilm? Like, do you think that it will just activate immune system, or do you think that it will somehow specifically bind to a biofilm? How can we improve that? I can't hear you if you're saying something.
Please, 1 second. We now try to fix our connection. 1 second.
Okay, we are waiting.
Dear opponent, can you repeat your question, please?
How do you expect immunoglobulin to work on a mature biofilm? I mean, do you expect it to just activate immune system, or do you think that it can interact somehow selectively with biofilm?
I know what this method is clear for doctors, because it's not only it's not new methods of against this disease, and we have already finished a solution of this, and you can buy this in pharmacy, and if you want to fight biofilm by this method, you can use it, because it's clear method.
Okay, so you say that there are some publications that say that immunoglobulin can help patients with a mature biofilm. Because I think that using immunoglobulin seems a rational decision for an infection where there are planktonic bacteria, because it can just activate immune system so that our body naturally kills these bacteria. But when bacteria in a biofilm, we can't just target it by using immune system because it is just really hard and really inert.
But all of drugs have some problems of this, and if we have a registered preparate, we should know what it's can be used in complex of drugs and tablets.
Okay, that sounds interesting. So we're improving to now using immunoglobulins and drugs. You had a really nice information about different methods of penetrating biofilms. Which exactly would you choose right now if you are using to choose that method and immunoglobulin to make it more effective? And why haven't you choose the other ones?
Can you repeat? I didn't hear you. I have a problem with my computer.
Oh, I'm sorry. So we decided to use immunoglobulin and some drug, right? So in your presentation, you had a wide range of methods for penetrating biofilms. Why haven't you choose these methods before? And which of these methods would you like to choose right now when you decided that immunoglobulin is not enough?
I think what is method the better because it's more it's a method in which we can more knowledge, and this method is using in our days for fight the biofilm
okay.
And I think what we can destroy biofilm by nanoparticles, and immunoglobulin can be used to these nanoparticles of silver.
Okay, so you decided to choose immunoglobulin and nanoparticles of silver. I think that's an improvement because they can actually penetrate biofilms, but they can actually be toxic to cellular membranes. Not so much, but it's a thing that you should consider if you are treating a patient with a disease. Okay. Do you expect these silver nanoparticles to act selectively on the biofilm that you want to penetrate, rather than on biofilms, for example, that our bacteria have in our stomach?
I think yes, because it has influence of all stain of bacterium which was presented in this task.
So you say that these immunoglobulin plus silver nanoparticles will act on all bacteria in our body, right?
Yes.
But first of all, it's not really good because we have good bacteria in our body. And second of all, okay, you destroy the matrix in which bacteria are held in, right? And then you expect immunoglobulin to activate immune system, and so our immune system just will kill them all, right?
No, but this method has a high specific on our microorganisms. It has influence on our organism, only for bacterium or microorganism.
Yeah, I know. I'm talking not about the silver nanoparticles, but okay, I'm just trying to understand the mechanism. So do you say that silver nanoparticles disrupt the matrix of a biofilm? Or they somehow get inside? How is it possible that they act?
Okay, if we destroy our microflora, we can use probiotics and prebiotics to improve this.
Okay, but if you will free all these bacteria, right, and you have a strong immune response on this, there is a big possibility of sepsis of a human body. Have you thought about it?
Dear participants, dear reporter, you have just 11 seconds. Dear opponent, you have 44 seconds.
Mm-hmm. What I was saying is that if we will free all these bacteria and if we will not detect them by, for example, some antibiotics or another antimicrobial agents, then there is a big possibility of sepsis. And so you must take that into consideration of your solution.
I think what then doctor will be select the therapy he can taking into the accounting the patient consider, for example, if doctor know what it can be used for this potent, he can choose other way to prevent this disease.
Dear reporter, your time's up. Dear opponent, you have 23 seconds.
Okay, I would like to say that, yes, doctors must be well educated on this method, but right now, I still didn't understood how do you expect all these bacteria to die when they were free of this matrix and they are a big danger for our body. And there's a big possibility of sepsis.
Thank you, time's up. And dear reviewer, you have 1 minute for preparation.
Good morning, everybody. I want to say
Just a second, you have 1 minute for preparation, not for speech. You can prepare just a little bit. Or if you don't need it, you can start. Dear reporter, you can start your speech. You have 5 minutes.
Okay. Hello, everybody. I want to say to speaker, thank you for your job. All be all right and understandable. I want to say about your advantages, your report. You say about anti-adhesive drugs, silver, nanoplanktons, antimicrobial peptides, bacteriophages. Embedded in the cell membranes in fragment. You said there are better than antibiotics, if I hear that. Can you tell us about it? Why do you think so?
Dear reviewer, you don't have you don't have to ask. You have not to ask questions. You just should just give us a review.
Okay.
You should just give us your
Okay, I
understanding
understand.
all of this.
I want to say that all job was make very good, and I haven't disadvantages in this work, and it's all what I want to say.
Okay, dear reviewer, have you finished?
Yes, I do.
Okay, so we can go to the conclusion words of reporter. You have 1 minute for it.
In conclusion, I would like to say what such methods are certainly used in the combined biofilm, and of course, until future, in there of can be able to provide other solution. But in our day, we have only this way to fight this biofilm. That's all what I want to tell you. Thank you for your attention, and thank you for work of opponent and reviewer.
Okay, thank you. Now we have time for questions from experts. Dear experts, do you have any questions?
Yeah, one small question to reporter. You talk about several approaches to this problem, and do you think we can use it in same time? Your 2 or 3 methods. Can we use it in same time?
I think what doctors should to choose one of or two methods, but I think what we can use a combination of these ways to destroy a biofilm.
Okay. Thank you.
May I also ask a question? You hear me?
Yeah.
Cool. So all of your approaches work against the bacteria. So you are treating the biofilms that were already formed. And have you been thinking about preventing the biofilm formation, for example, by means of changing bacterial metabolism somehow, saving the good bacteria and eliminating the bad ones, something like that?
Yes, I think about this problem, and we have used anti-adhesive preparates, so which was in the start of my presentation. They can prevent formation of biofilm structure.
No, so this all I saw at the beginning of your presentation that all these preparates are quite aggressive. I suggest to think of some like metabolic changes, for example, on the level of regulation of bioinformation, but not just strict preventing. Okay, something maybe some diet or something like that. Probiotics, for example, in Austria, as I know, bacterial bioinformation can be treated by lactobacillus, something like that. Have you been thinking in this direction?
Sorry, but I didn't heard about solution of this kind, and I didn't know about this process, how we can stop it.
Okay, but I think it's one of the approaches that is now widely used in by people. We choose proper bacteria and eliminating the bad ones, and thus we treat biofilms. So maybe this is this approach is milder than you suggested. Thank you. Thank you.
May I ask a question too?
Yeah, of course.
I have a question to the reporter. Could you explain to us, please, the causes of the drug resistance? Because I know that it's quite a complex process, and maybe analysis of the causes of the antibiotic resistance could help to search for the solution.
I think what we firstly should do destroy a biofilm, and in the over step we should use antibiotics, because biofilm to support a microorganism community, and a lot of mutation can be can have influence of this process.
Is it all what you wanted to say? Yes?
I think yes.
Actually, that wasn't my question. My question is that maybe first of all, before you start to search for the solution, you should read about the causes of the drugs resistance, because it's not so simple, and there are a lot of literature considering this topic, and you will see if you search that this is multi-step process, and maybe if you will analyze that, you will see that your solution, how to improve your solution. So that's all. Just a little advice.
Okay, the experts, any questions?
Okay, thank you. I heard about some people who use antibiotics without doctor's therapy, and it can have influence on resistance of microorganisms. It's you mean?
No, I mean that actually it's connected to the comment of the previous expert, because the resistance to the antibiotics is the biofilm forming is quite a complex thing, because there are it has a lot of aspects. For example, the first one is the mechanical prevention of the penetration of the antibiotics inside, and the other one is slow downing of the metabolism, and the third aspect is that the concentration of the antibiotics which are still goes inside is lower, and that there are some cells inside which are forming this resistance. And I guess that before to search for the solution, you should analyze the mechanisms of this process, of the formation of the film, and then you should search for the solution. That's all. For me, it's just advice. You should to explain us about the reasons and the mechanisms, not me. Okay.
Okay, thank you for your advice, and I will be more have more knowledge in this process in future.
Okay, thank you. Do you have any questions, experts? Okay, so now we are finishing with this. And dear experts, you have 1 minute for understanding of your scores for these participants. Okay, hope you are ready. Let's start from Mr. Berezhnov. Please tell us your scores for the reporter, the opponent, and the reviewer.
Thank you. Okay, I'll give 7 points to reporter, also 7 points to opposing team, and 3 to reviewer.
Okay, thank you. Mr. Zayats, please.
Yes, 6 points to the reporter, 8 points to the opponent, and 2 points to the reviewer.
Thanks. Ms. Petrova, please, your scores.
I award reporter 6 out of 10, and 7 out of 10 for the opponent, and then 1 out of 5 to the reviewer.
Okay, thank you. Mr. Aladdin, please.
So my score, to reporter 5 points, to opponent 7 points, and 2 points to reviewer.
Please repeat your scores for the reviewer.
2 points to reviewer.
Okay, thank you. Ms. Tutukina, please, your scores.
My scores are 7 for the reporter, 8 for an opponent, and 2 for the reviewer.
Okay, thank you. Mr. Malevin, please.
6 for the reporter, 9 for the opponent, and 1 for the reviewer.
Okay, and Ms. Bokan, please.
6 for reporter, 8 for reviewer, and 2 for, oh no, I'm sorry, 8 for opponent and 2 for reviewer.
Repeat, please, your scores.
6, 8, 2.
Yep, thank you. Okay, we are done with it. And now the last one challenge for this circle. Just a second. Okay, now the opponent is Rubisco and reporter is Vichuikova. The opponent, you can challenge the reporter for all of tasks except 1, 2, and 6.
Okay, our team Rubiska, order our team reporter, V. Chuikova, on task number 4, life in plastic. It's fantastic.
Okay. So, dear Team Vichikova, are you ready?
Yes, we're ready. I'm Olga. I will tell you about life in plastic.
Okay, what is your name, please?
Olga Chechekina.
Okay, who will be the opponent?
Opponent Team Rubisko, Dmitriev Kirill.
Okay, and the reviewer?
Reviewer from my batch
А, в смысле, я включить, понял.
Will be Сычев Валерий, it's me.
Okay, good. So the reporter, you can start to prepare. Remember that you have 8 minutes.
Okay, so now you can see. Yeah, okay. So nowadays humanity produces a huge amount of plastics, which eventually end up as pollutants entering our natural environment and oceans, leading to growing concern among scientists and ecological activists. Here, we were given a task to suggest a certain method to uniquely exclude quickly disintegrating plastics from the normal one for being able to recycle the normal plastic. Now, humanity gets close to the understanding of the amount of damage plastics does to us and to the entire planet. There even are accounts that by 2050, the amount of plastics in the ocean will overweight the amount of fish. Thus, governors of the international organizations and heads of states may voice an alarm and take immediate steps, and maybe radical steps, to at least stop and better reverse the destruction of our only home, our planet. And so, our solution of the given problem implied the tight cooperation of heads of states and scientists, as we proposed first ones to take immediate steps, such as producers of quickly disintegrating plastics might be obliged to add fluorescein or any other fluorescent dye to the plastics. This might not affect the quality of the plastics, but it makes no harm to human health, but it will make the first step of the proposed digestion possible and the whole procedure more effective. So the first step, which we're talking about, propose the sorting of plastics according to its luminosity. The camera set above the sorting belt detects the fluorescence of self-disintegrating plastics caused by UV radiation. And then the information about location of shining plastics is being transmitted to air sources, which then specifically blow out the quick disintegrating plastics. This step eliminates the vast majority of the undesired plastics, and the white fraction, mostly consisting of normal plastics, then undergoes further purification if it's needed. Once again, the white fraction, we mean mostly consists of usual plastics and can be further purified from residual biodegradable quickly disintegrating plastics. For that purpose, we decided to use two model polymers, polylactic acid and polyhydroxyalkanates. For polylactic acid, it's known that in this article, it was shown that they can be biodegraded in sludge waters with Pseudomonas in 15 days. And for polyhydroxyalkanates, it's shown that they can biodegrade in soil with Pseudomonas in 28 days. And thus, the proposed digestion protocol looks the following way. White fraction might be green to dust to maximize the functional surface of the plastics. And then it might undergo the UV irradiation to reduce the molecular weight of the polymers, and then the fermentation process takes place, followed by filtration of the normal plastics, much more pure, and to remove the other solvents. Yeah, the fermentation broth might include sludge waters from fabrics, for example, Pseudomonas, and other desired cultures, which would be tested for the compatibility and experimentally evaluated. And prepared enzyme mix, for example, polyhydroxyalkanates depolymerases, and additives like gelatin, elastin, silk fibrin, amino acids, and peptides for the microorganisms to excrete, to be able to live and like develop, and to excrete extracellular depolymerases to break down the polylactic acid and polyhydroxyl kinase and some other polymers that can be met amongst the whole plastic fraction. So all in all, the proposed method has, of course, a big disadvantage, like radical steps and global concern are needed from the governors, but this method still might work even without that. Like we should not like blow away these lightning plastics. Yeah, and as for me, this proposed method has a lot of advantages, like it uses sludge waters, so kind of eco-friendly, and it has cheap reagents and simple procedure. Yeah, and that's pretty all I wanted to say. Thank you for attention. Ready to talk further.
Okay, thank you for your report. So, dear opponent, do you have any questions?
I want to prepare.
Okay, so you have 2 minutes for preparation.
I'm ready.
Okay, so you can start.
Dear reporter, please say on the 5th slide, what the code chemical substance? I can't see code substance.
Dear opponent, now is your time for your opponent's speech. It means that you should speak about advantages and disadvantages of this decision, or some minuses or pluses of this report. So you will have time for asking questions and for speak with the reporter, but in polemic. But it will be later. Now it is the opponent's speech.
Okay.
So, dear opponent, are you ready for speech?
Yes.
Please start.
Okay. Same the question. On the 5th slide, what the code chemical substance? I can't see code. I see chemical formula, but I can't see code chemical substance. Yes, yes.
That's fluorescent. Actually, I can't answer your question now, but it's fluorescent. Yeah. Now should your opposite speech. Yeah.
Okay. Another questions. Give another examples plastics which quick disintegrating.
Dear opponent, as I understand, you don't have any kind of opponent speech and you want to go to the polemic. Am I right?
Okay.
Okay, let's start the polemic.
Give another examples plastics which quick disintegrating. I can see 2 examples. Or you say another examples.
Well, there are plenty of it. For example, there are lots of abbreviations which might like tell about nothing. For example, PSAB and others. Yeah. So probably let's move to the solution, not the details, which are not kind of referred to the.
Okay. I can say that this solution the problem very good, but advantages and disadvantages say dear reviewer. That's all.
Can you please once again repeat? I didn't get the idea what's happening.
Repeat my phrase?
Yes.
I can say that solution this problem very good, but advantages and disadvantages say dear reviewer. Okay?
You mean you asked me to repeat the advantages, disadvantages? Reviewer. Okay. So there will be no polemics.
Actually, dear opponent, I need to remind you that speak about advantages and disadvantages of this report. It is your task, but not reviewer.
Okay. So I say that good slide this device number 9 and yes, and I say that no schemes, no tables. I think that we must from the solution this problem.
Well, by tables, you probably mean like amount of reagents added to the broth, or like films of bacteria added. Well, of course, that's a huge experimental process for estimating the optimal conditions, and I just kind of mentioned in my speech some of the probable techniques and some reagents which might be in this broth, which I found according to some articles and some other experiments. But like I see no reason for like drawing some tables with the contents and precise content of the broth. And yeah, by schemes, I don't know what you exactly mean. Probably I in general showed the way my solution works. Maybe you can elaborate on what you want. Maybe I can go into more details if you explain.
Okay, okay.
So maybe you want from me some questions like about schemes you mentioned.
Yes.
Yes. Which schemes? What do you mean by them?
Yes.
Which schemes? But maybe something is not clear in my solution. Like, what do you want to hear?
Which schemes?
Yes, which schemes?
Oh. Well, schemes about information plastics.
Yeah, I see. You asked me to mention some more about disintegration plastics. Well, I mentioned these two because they are like most common, mostly used, and the most green ones. Yeah, and I just found information about these two as they present the biggest fraction of the whole plastics. And some enzymes and some applications and lots of articles about their degradation in some artificial conditions are known. Yeah, but if talking about some, if you go into some real large-scale processes, of course, we might take into account much more types of plastics and also care about their digestion. Yeah, probably. But that was not the goal of the task. The task was to kind of find the sorting methods and kind of separate the normal plastic from the with disintegrating one. So I think, yeah, no. Any other questions?
Another question.
Yes.
Can you tell us a little about filtration?
Filtration, okay.
On the 10th slide. Yes?
They are pretty similar. When they get these dusts of plastics with large surface, we put it into the fermenter, supplied with some sludge waters and additives for the bacterial growth and bacteria and some enzymes, hydrolytic, which help to reduce and to biodegrade the plastics, quickly disintegrating plastics. And thus we get we get molecules with much lower molecular weight, and they are kind of become soluble, and thus we can filter out the normal plastics, which does not degrade in such short periods of time, like 15 days or 20 days, and thus it will just stay the same. And after this period of time, we can just filter out the normal plastic, and the biodegradable, like nanoparticles or just molecules, can be filtered out through the pores. Any others questions?
Okay, thank you.
Thank you. Yes, it's pretty old.
Dear reporter, you have just 27 seconds. Dear opponent, you have really much time.
Well, if opponent have some ideas, what can I elaborate more on, please? Some ideas? No? Well, yeah, maybe some ways for me to improve my solution, if some advices, I don't know.
Okay. As I understand, we have finished our polemic. If the opponent doesn't have any questions. The opponent, do you have any questions, or we can move on?
Yes, some questions.
Okay.
This question, if you haven't this device, can I sort in plastics if I haven't this device?
You mean this or the second one? This one.
This slide.
Okay. If you don't have this device, well, first of all, plastics can be sorted on the belt. It's pretty effective if the person is at it. Much more effective and
I'm sorry, but your
time
time's up.
Okay.
Dear reporter, your time's up. So, dear opponent, you still have time. You can say something if you want.
No questions.
Okay, thank you. So, dear reviewer, you have 1 minute for preparation. Dear reporter, if you are ready, you can start.
You meant reviewer?
Yeah. I'm sorry. Reviewer. Please turn on your camera. Okay, thank you. You can start.
I'm here. Good afternoon. My name is Valerie, and I'm representing the team My Biochemical Romance. First of all, I want to thank the speaker and opponent for their work. And I would like to start with the speaker. So I want to say that quality of her presentation was very high. Presentation was made logically. All information was clear, although I couldn't see references in your presentation. And maybe dark background isn't very good for slides, but I think that your presentation in commas is very good. So now let's see on your decision and what did you conclude with our opponent. So as for me, polemic wasn't very productive because both speaker and opponent didn't conclude some main disadvantages or advantages of this decision. Firstly, as we all can see that opponent wasn't said his words and his opposing according to the rules. But I can say that he asked one good question that I myself had during this decision. And so I want to say some words now about your decision. I was really excited by it because, as for me, it's very original. I can see that you think it over yourself. And now I want to point out some questions that I hadn't. Maybe it's better to consider it. So as we know, we have a lot of kinds of plastic that we can refer to biodegradable. So some of these degrade, the first step of degradation, with help of water. Some kinds can degrade with help of ultraviolet radiation and oxidation. So that is why maybe your recycling method connected with fermentation is not available for all kinds of plastic. For example, we know that oxoplastic and photoplastic, photobiodegradable and oxobiodegradable, can degrade very long time. So and they have other bacteria to degrade on the second step of the degradation. So maybe it's okay that you don't actually know about that, because we are all students, and we can't exactly know what disadvantages will we have during this fermentation. But maybe it's worth to say, and it's worth to consider it during your decision. Moreover, according to the information that we have a lot of kinds of degradable plastic, maybe there is sense for extra sorting. So we all understand that we necessary to consider in our practice, but we haven't ability, unfortunately. And so there is a problem to solve. You know that unfortunately, even in Russian Federation and maybe other countries, different manufacturers can produce mixed plastic. For example, from biodegradable and non-biodegradable with different additions.
10 seconds.
Okay, so I think that the problem is solved, and I thank you for your attention.
Yeah, thank you. Now it is time for conclusion word of reporter, please.
Hey, once again, thank you for the warm words. Yeah, I would like to tell about mixed plastics. I think this the solution to this problem is included into mine, because I kind of agreed to that, the whole plastic fraction, and thus no matter like what it consisted of, this method just helps to separate. Never mind if the bottle was like partially done from different types of plastics. Yeah. Also, you mentioned that there are different types of plastics. Yes, of course. And I think I've chosen two, like, model of not the simplest one. They're pretty crude, and they're like much easier, like starch plants, which might biodegrade much easier. And thus, even more, my solution includes water digestion, UV radiation, plus fermentation.
Thank you, reporter,
okay, yeah,
for your speech. Okay, and now it's time for expert questions. Dear experts.
Okay, can I ask questions? I want to talk about how to say oh yes. Separating, yes, separating plastic that biodegradable from regular plastics that we must recycling too. So in your ferment apparate, what did you sorry, what did you do with regular plastic? You just wash out it from this substance?
Well, we get the fraction of dust of biodegradable plastic and non-biodegradable, like usual normal plastic. The normal plastic is finally can be after the fermentation can be filtered out and washed out and be melted or upcycled or recycled.
Yes.
And the biodegradable one is now in solution. And firstly, it was blown out on the belt with the air sources. That one can be separately biodegraded some way. Our task and the one which is in solution, most of the enzymes used for this biodegrade these polymers into some common.
No, it's not interesting. I'm about mechanism of separating. For example, it's okay if we 50% of biodegradable plastics and 50 regular. Okay. But for example, if we 99% of regular plastic and only 1% degradable, you should use very big apparatus, cisterns, for example, tanks for this thing. It's strange.
You mean that it's irrational to use such big tanks to eliminate 1% of the biodegradable plastic?
Yes, if we have a low percent of biodegradable plastics.
Probably.
And maybe you don't used to work with wastewater sledge, but I used to work with shovel, and all Romans in my heart. It's very hard.
Well, as I mentioned, I hope that the amount of biodegradable plastics will kind of become bigger. And moreover, I mentioned that when we blow out the biodegradable plastics, we do it to some degree. And then if we want, we can make the plastic fraction even purer using these tanks if we want. If it is our purpose, we will use whenever big tanks we want.
And you need fresh water to wash out it. You understand? It's
wash out. You mean after fermentation?
Yes, for wash out normal plastic.
Yes, understand. You mean
water resources? Yeah.
Yeah, water resources. But of course, we can use recycle for water. Like no problem.
Naive girl. So thank you.
Thank you.
Okay, any questions?
I have a question. Me. Do you expect something toxic in the output of your system?
Output of the system. Well, according to the strains and organisms used for the fermentation, of course, there might be some toxic compounds. And also, I know that some plastics have some bad additives, like I can't remember, but like two-phenyl rings and biphenyl A, which is very toxic for people, and it is oftenly added to plastics. Yeah, that might be a problem. But if we introduce the recycling system of water, that might work out well.
Okay, and the second question, what is the expectation of the cost of the system approximately? Very approximately, I know.
Well, like for me, it seems to be not very expensive. Like the waste will be on water, which we can recycle, so electricity. The reagents of like sludge waters, we need mostly sludge waters, not pure water, which is pretty close to zero spends. Cultures of different strains, which kind of grow on the some sugars and amino acids. So we need them. Like the general cost, it will be difficult to like even approximately But I think that if that would be a global project, then this would be efficient.
One more question.
Yeah.
May I ask you? You have a very good solution, and your solution is very complex and consists of different stages, several stages or parts. Could you please clarify once again which part of your solution is your own invention and which one you get from literature?
Well, the general idea of sorting by air sources is not new. Like on usual fabrics manufacturers, people just blow out according to the color of the plastics or color of other trash. I decided to use UV light that was not used previously, and this camera which detects the fluorescence. Then I gave an example of people in articles, not on the manufacturers, just in articles, they found that plastics can biodegrade in soil or in just solutions in some adequate time. So I decided that that's good for me. I can use it in like large scale processes. And yeah, I just got the idea that I can, it's better, they used in these articles like films or like some, I don't know, like tablets of plastics that seemed to me irrational. Thus I decided to do green into dust for the surface of the plastics to be larger. And yeah, the fermentation itself, fermentation is not a new process, but I think multicultural process is not very common because it's difficult to adjust the like the pH, the temperature, the amount of amino acids and some other compounds. But if do a big research on that, I think it will work out.
Thank you very much.
Thank you.
I also have a question. You propose to use some strains of microorganisms for PHA, some for PLA. How compatible are cultivation conditions for these microorganisms?
For example, for both of them, Pseudomonas are suitable. And I think if to do a more complex literature research, we'll find some other interactions like between them. But I also found that about PHA, very good biodegraders are marine organisms, and that's a pretty bad news because they work really well, but they need concentration of 0.5 moles of sodium chloride per liter, and it's pretty high for normal one, I guess. Yeah. So yeah, that might be a tricky question, which need further research.
And another question, have you considered psychological implications for the population about fluorescent footwear? Maybe there will be some phobias among general populations.
Well, for me, I haven't thought about that, but your question caused excitement inside me because it would be very beautiful. Well, problems. Probably yes. Some people might be scared by that, but if to make a global concern about like from the positive point of view, if everybody will know that it's funny, it's lightning, and this biodegradable plastics good, we're doing good stuff. Probably there will be not that much problems. Yeah, I think so.
Okay.
Thank you.
Okay, we have time for the last question.
I have one more question, if it's possible. As I understand, you want to change all the system, like all the pipeline of the creation of this biodegradation plastic, but you do expect that it changed the cost of this plastic? Because I don't know if you know or not, because from the previous months, the cost of the plastic really rise very high, and no one know why. Maybe you expect or not this in your system.
Well, for me, the pipeline of the bioplastic preparation won't change that much. We just need to find proper conditions for adding a fluorescent or other dye to the plastics. I think that that's composite chemistry. I'm not very familiar with that, but probably that won't really change the process. Of course, it needs some changes in the production, but probably it won't make it much more expensive. Like I don't think big amounts of fluorescent are needed for that. And yeah, but yeah, I think it will work out because the costs of plastics are not comparable with the problems we do to the nature. Yeah.
Okay, thank everybody for their job. So now, dear experts, you have time for thinking about your scores. Вот они сидят вдвоем. Надо сказать об этом. Okay, dear Vichikova, I see that you sit down like behind each other, and actually it is not good for you because reporter should report without any kind of words from your sides, and it's some kind of unfair. Of course, we can control it, and it's just on your I don't know, on your decision, but actually it is not good. Please don't do it like that at another time.
You mean just when we report, others should not say something? Yeah.
Yeah, say something and sit right the next by you because it is not good.
Okay, sorry, we haven't seen it in the rules, but we won't do that again. Thank you.
Okay, because now we don't have special rules for online conference because it is the first time in our practice. But actually, you have these rules in the regular ВioTournament, and you know it, of course. Okay, dear experts, I hope you are ready. And let's start from Mr. Berezhnov. Please, your scores for the reporter, the opponent, and the reviewer.
Okay, thank you very much. I put the excellent mark 10 to reporter, 1 to opponent, and 4 to the reviewer. Thank you.
Okay, Mr. Zayed, please.
10 to the reporter, 2 to the opponent, and 5 to the reviewer.
Okay, Ms. Petrova, please.
9 points to the reporter, 3 points to the opponent, and 4 points to the reviewer.
Okay, Mr. Aladin, please.
Yes, so to reporter 7 points, opponent 3 points, and reviewer 3 points.
Thank you, Ms. Tutukina.
9 for the review or for the reporter, 3 for the opponent, and 5 for the reviewer.
Okay, thank you, Mr. Malavin.
Reporter 9, opponent 1, and reviewer 3.
Okay, and Ms. Bokun, please.
To reporter 8, to opponent 1, and to reviewer 3.
Okay, thank you for your scores. Actually, we are finishing this scientific circle. You have a break, and you have a break till 2 p.m. We'll continue at 2 p.m. But actually, you should check your Telegram Telegram message because you will be sent the link for the another section of this scientific fighting. So please just check it. So good luck. See you guys. Maybe.
Excuse me.
Okay.
What if I don't have a Telegram or?
We will send it to you in VK.
Thank you.
It's not a problem.
Mm-hmm.